Suppose if you integrate small fx, you get big fx plus c. Then the definite integral of fx from a to b is just integrate a to b small fx dx equal to bfx. Then you put b on top, a below. And basically what you do is you sub x as b, and you sub x as a, so it's just bfb minus bfa. So when you put out the definite integral of small fx from a to b, the answer will be just bfb minus bfa. When there's no lower upper limit, we call it indefinite integral. When there's lower upper limit a and b, we call this definite integral. So if you integrate small x dx, you get half x squared plus c. This is indefinite integral because there's no lower and upper limit. And if you have a lower limit 3, upper limit 5, to work out the definite integral of x from 3 to 5, you just use your answer, which is half x squared, right? Integrate x gives you half x squared, and then you just write 3 below, 5 on top, and to work out the answer, you just sub x as 5, so 5 squared. And after that, subtract sub x as 3, and take the square because x squared. So it will be 25 over 2 minus 9 over 2. So it's 16 over 2. So answer is just 8. We shall now look at some terminology of definite integral. So if you integrate a to b small fx dx, the interval integration is from a to b. And a is called the lower limit of integration, b is the upper limit of integration, and x is the variable of integration, and fx is the integrand. And you'll find that x is actually a numeric variable. You can write integrate a to b fx dx, or integrate a to b f bracket u du, or integrate a to b ft dt. They all represent the same thing. The reason is because eventually you get a number as an answer. If you integrate x from 3 to 5, integrate x gives you half x squared, then you write 3 below, 5 on top. So basically you sub x as 5, you sub x as 5, right? And after that you sub x as 3. So you sub x as 5, you sub x as 3, and eventually you get answer 8. So instead of using x, if I ask you to find 3 to 5 t dt, then the answer will be integrate t will give you t squared over 2, right? It gives you half t squared, right? Then 3 to 5. Then you sub t as 5, then you sub t as 3, then you find that you still get 8 as the answer. So it doesn't matter you use x or you use t, then you still get the same answer. So that's what this equation here is trying to say. X is just a dummy variable. You can use x, you can use variable u or t. Eventually, the answer is the same. So this small x or small t here is just a name for working. So it doesn't matter you use x or use t or use u, or you use integrate w d w from 3 to 5. You find that it work out, the answer is still 8. So it doesn't really matter what variable you use. And for such cases, we call it a dummy variable.